Hey everybody, it's Farm Friday. Today we're at the Safe Food Alliance checking out some testing they're doing for us on our plums. Let's go take a look.
My name is Wiley Hall. I'm the Director of Research Chemistry for DFA of California and Safe Food Alliance. So what we're doing today for HMC is we're looking at the antioxidant compounds found in different varieties of plums. So they've sent in 4 different varieties of plums for us to look at. And after some extraction, we're going to run them on this. This is my newest toy, so I'm very excited to get a chance to use it for something like this. So this is an Orbitrap mass spectrometer, and what makes it special is it's what's considered a high-resolution mass spectrometer. So what a mass spectrometer does is it takes compounds that go into it, and it first of all tells you what the mass of those molecules are, and that's going to be specific to the type of compound that it is. So water has a mass of 18, glyphosate has a mass of 168, etc., etc. So first it tells you it can tell you the mass of the compound that is there, and it can also break it apart and tell you the mass of the pieces. So you can put it back together and kind of figure out what it is from there. So all mass spectrometers do that, but what's different about the high-resolution mass spectrometers is that it gives you a very accurate reading of the mass. So both water and ammonia, 2 very different compounds, have a mass of 18. But if you follow that out to a couple decimal places, you start to get a difference in the mass. So this is able to tell the mass of the compounds that go into it accurately enough that you can actually determine what their formula is just from the mass alone. So very exciting piece of technology, and we'll use it to look at what we extract from these plums, and then I'll try and go back and determine just which of number of possible antioxidant compounds there are. And it'll also give us some idea of how much there is, at least in comparison to each other. So we can see that one has more anthocyanins and one has maybe more chlorogenic acids. You always want to make sure you're only analyzing the edible portion. So that usually means removing pits or shells, or sometimes peeling the commodity depending on what it is. So we have a high-speed knife mill, which we use to turn those half plums now into this homogenator. We need to make sure that every little bit of this is like every other little bit, right? We need to make it as uniform as possible. Once we've blended it, then now we can take the couple grams that we're actually going to use for the analysis, and the rest will just go into library storage for a couple weeks in case we need to repeat the analysis for any reason. The mass spectrometer is incredibly sensitive. Detection limits down in the low part per billion range, which is equivalent to 1 molecule of air in a room. So really it's only about 2 grams that I'm going to use for the actual analysis. And then we add our extraction solvent, which in this case is a solution that's 80% methanol and 20% water. So, Sonicator uses, as it sounds, you can probably hear it, sound, sonic waves to, we use it for extractions. It's putting a lot of energy into the hopefully very fine particles of plum that we have left over. And all this, again, is just to, move any compounds, especially the antioxidants that we're looking for, from the solid plum material into the extraction solvent. I've transferred the sonicated extracts into centrifuge tubes, and we'll put them into our high-speed centrifuge. And this is really just to separate the liquids from the solids, spinning around at 3,000 RPM for about 5 minutes. Now that we've centrifuged them, we've mostly separated the extract from the solids. So we'll do a quick filtering to get every last particle out, and then it'll be ready for analysis. I'm going to remove the extract from the solids and just push it through a So normally we have basically a robot arm, an auto sampler that does all this for it. But in this case, we have what's called an ion chromatograph, which is used to separate things based on their charge. And I don't want to use that in this case because I'm worried it's going to trap some of the compounds that we want to see. So I'm going to do a manual injection that kind of bypasses the ion chromatograph here. When I inject it into here, it's going to fill a sample loop that controls the size, the amount of extract that goes into the instrument. And then it'll flush it with solvent into the mass spectrometer. Takes me about, what was that, 10 seconds to make the injection, and then I'll spend maybe a couple days going through all the data to try and turn the results into something meaningful.